All right, we're on intermediate lesson 8, triangles. Tri from the Latin meaning three, angles from the Greek meaning angles. A triangle is a closed figure made up of three segments, meet at their endpoints, and there are three angles. Some facts about triangles. Let's say that in this picture, let's add this to the picture. Opposite the angles, we're going to have the same letter but lowercase. So there's a theorem or a postulate from geometry that says that in a triangle, opposite the biggest angle is the biggest side. Opposite the smallest angle is the smallest side. Opposite the middlest angle is the middlest side. So if I tell you that angle x is 100 degrees, and angle y is 50, and angle z is 30, we don't know what the lengths of the sides are, but we do know that z is the smallest, y is the next smallest, and x has to be the biggest side. Sides and angle relationships. Well, let's talk about some special triangles. The scalene triangle is a triangle in which all the sides have different lengths. An isosceles triangle, I'm having a hard time writing. Isosceles has at least two sides the same length. So this third side could be the same, it could be different. An equilateral triangle has all sides the same length, therefore all the angles are also the same. The isosceles triangle theorem says that in an isosceles triangle, by the way, the two sides are the same length, those are called legs. Leg 1, leg 2. The isosceles triangle theorem says that in an isosceles triangle, the two base angles have to be the same. The base angles are the angles opposite the legs. There's also a converse to the isosceles triangle theorem that says that if you have a triangle in which you have two angles are the same, then the sides opposite those must also be the same. So this triangle theorem, isosceles triangle theorem, works in both directions. If you have two angles are the same, you know that they have to have two sides that are the same. If you have two sides that are the same, you know you have to have two angles that are the same. Going back to equilateral triangle for a minute, talked about it for a moment, perhaps prematurely. If all the sides are the same, all the angles are the same, since all the angles add up to 180 in any triangle, that means that in every equilateral triangle, each angle has to be 60 degrees. Alright, so let's look at this picture. Let's say that we were told to find the values of x, y, and z. Done. They're all 60 degrees. The reason that they're all 60, this is an isosceles triangle. It's an equilateral triangle. Also, it's isosceles as well, but it's equilateral. All the sides are 5, therefore all the angles have to be the same. They all have to be 60. Pythagorean Theorem, the most famous theorem of all, aside for Rudolph, says in a right triangle, must be a right triangle. It's a triangle with a right angle. If you take a leg and square it, add it to another leg that's squared, it will always equal the hypotenuse squared. In a right triangle, the legs make up the right angle, and the hypotenuse is opposite the 90-degree angle. And the Pythagorean theorem It says that in a right triangle, if you square each leg and add them together, it equals the hypotenuse squared, which leads to Pythagorean triples. Pythagorean triple means that you have a right triangle in which each side of the right triangle is an integer. It's a rare thing for them to be integers. Well, let me give you an example. The most famous right triangle of all is the 3, 4, 5 right triangle. Let's just see if that works. 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. 25 does equal 25, so it checks out. It's called a Pythagorean triple, the 3, 4, 5 triangle. Now it's not just 3, 4, and 5. If you multiply those by 2, you're going to get a 6, 8, 10 right triangle. If you multiply 3, 4, 5 by 3, you get a 9, 12, 15 right triangle. You should recognize Pythagorean triples when they are in front of you. Another base example of Pythagorean triple is the 5, 12, 13 right triangle. It's also Pythagorean triple. Any multiples of those are Pythagorean triples. Alright, let's get to an example. In the figure below, what's the length of segment AB? Well, at first glance you might think this is a Pythagorean triple. Hey, there's a 3, there's a 5, this must be a 4. False. A couple reasons why it's false. One, opposite the biggest angle has to be the biggest side. If 90 is your right angle, that's your biggest angle. 4 is bigger than 3, but it's not bigger than 5, so it doesn't make sense. For the Pythagorean triple to work, the 5 has to be the hypotenuse. So the Pythagorean theorem, we're going to square each leg, and that should be equal to the hypotenuse, which they're saying is AB. So that's a 9 plus 25, which is 34. If you square root both sides, you get AB is the square root of 34. That is not a perfect square, nor does it simplify. So let's just leave it at that. AB is the square root of 34. In the figure below, what's the value of x? Once again, this looks like it could be a Pythagorean triple, but it's not. X squared plus 5 squared equals 12 squared. Make sure when you write the Pythagorean theorem, the hypotenuse is always the one that's by itself. You get x squared plus 25 is 144. Subtract 25 from both sides, and you get x squared is 119. Square root both sides, you get x by itself. You get x as the square root of 119. That's not a perfect square. Also, it does not simplify, so that is our answer. Let's see, let's do another example that's not on your paper. Find the area of the triangle. And let's say that our triangle is this one. I don't know if we've mentioned it yet, but to find the area of a triangle, many formulas. One of them is 1/2 the base times the height. The base and height must be perpendicular to each other. So if we call this the base, that means 15 has to be the height. We don't know what the base is. Well, if we use the Pythagorean theorem, we can find out what that is. Now, you might recognize this and you might not. This is actually Pythagorean triple. This is actually the 5, 12, 13. 5 times 3 is 15. 13 times 3 is 39. That means that 12 times 3 is 36. That means this is 36. If you don't care for that, use the Pythagorean theorem and you'll find that it's 36. Question is to find the area. So it's half the base times the height. Half 36 is 18. 18 times 15 is 270. That is the area of the triangle. Well, great news. Just when you thought your life couldn't get any better, I'm done. Do exercise set 8. 8 reminds me of Joey Bell, Albert Bell if you will. Used to play for the Indians a long time ago.